Sorry about that. I hope everybody's having a good afternoon. This is a really great event, and I'm glad to be here. I just found out this morning I'm speaking for Tony Liu. Tony is the principal at Partner Energy, and I am one of his senior energy engineers. My name is Chetan Kadakia. I have about 12 years of experience in energy engineering, design, project management, and just general energy management. And today we're going to talk about existing buildings and implementing energy efficiency projects, something that I've got a good amount of experience in. Today's agenda, we'll be talking about benchmarking, energy audits, project capitalization, implementation, and at the end of the whole session, we'll have a brief question and answer session. So, when we talk about energy savings for an existing building and doing projects, what's that process? The process that we go by starts with benchmarking, understanding where you are, where's that baseline in comparison to everybody else, in comparison to standards, in comparison to the modern status quo, and in comparison to the future. Once you've benchmarked your facility, the next logical step is to perform an energy audit, getting detailed information on site, performing an analysis, and finding out what you can do at your facility or at your building to save energy or help somebody save energy. Once you understand the measures, you need to look at your project capitalization. How are you going to pay for that? What rebates do you have out there to help you? Your tax credits, any other options. And then once you've done all the homework, you've gotten all the numbers, you made the decisions, the implementation has to happen. That's the implementation of the energy efficiency project. So like I said, we start with energy benchmarking. The first thing you want to do is quantify your cost, your energy consumption, and your emissions. Is your building using too much energy? Is it using no, I shouldn't say not enough, but is it very efficient? Where do you stand as far as greenhouse gas emissions are concerned? Especially compared to other buildings, other properties, other portfolio of properties. The tool we use is Energy Star Portfolio Manager. And Energy Star Portfolio Manager is a benchmarking tool that helps you track changes in energy consumption, greenhouse gas emissions, and cost. Energy Star is a really useful tool. It takes in information like your utility bill data, the square footage of your building, how many data centers you have, occupancy, and it compares it to other buildings of similar types and tells you where you are. And the metrics that Energy Star provides are Energy Star performance rating of 1 to 100, and what that is it's a percentile based in comparison to other buildings. So if your building or a building is 75 out of 100, that's a good rating because that means the building is in the top 25 percentile. And at that point, 75 and up, the building can qualify for what's known as an Energy Star plaque. If, let's say, the building is not operating very well and you have an Energy Star rating of 40, that's an indication that you're below average compared to other buildings. And there are a lot of opportunities that you can take to improve on energy efficiency. From Energy Star, you also get an energy intensity, or how much energy you're using per square foot. That includes your gas and electricity, the cost per square foot, and your greenhouse gas emissions, or the equivalent of CO2 emissions per year for that facility. Here we have a building comparison over here. As you can see, you have buildings A through F, and buildings A, C, E, and F all operate in the middle of the road. So, you're looking at Energy Star readings probably of 40, 50, 60, etc. Here you've got one that's red. It's using a lot of energy. It has a lot of cost per square foot. That building probably has an Energy Star rating of maybe 30. Coming over here, you got a nice small bar, a green one. This one's more efficient, it costs less per square foot, and your Energy Star rating is going to be higher, maybe 75, maybe 80. So what do you do once you finish your, you get your benchmark and you want to do the next step? The next step is your energy audit. The energy audit allows you to take that 40 rating and explore further, deeper down into your building and identify what needs to be done. And this is useful for the owners because it helps them make a business decision. The business decision consists of several factors. Your capital budget, how much money can you spend on energy projects? The financing, how are you going to pay for it? Investment return criteria, how long does it take to pay back if you're implementing a new chiller or a lighting upgrade? What's your social impact? How much energy are you saving? How are you helping society? What's your corporate responsibility? And marketing. Again, so the energy audit consists of data collection, and the data collection consists of, well, what we start with is plan review. We look at a building's drawings. We see if, we look at their lighting plans, their mechanical plans, architectural. We look for things like building insulation, construction of the windows, operation schedules, mechanical equipment. A lot of things are found in the building plans. All this information has to be confirmed, or not all, but a lot of it's confirmed through a building walkthrough. And whatever information we're missing, we try to obtain through the building walkthrough and survey as well. For example, we walk into a machine room. The machine room may have 3 chillers, and those chillers will have nameplate, make, model, and tonnage ratings, and we take that information down. In addition to getting all the building information, as far as systems and insulation and whatever is on the plans and whatever you see as you walk through, we talk to the property manager and the building engineer. The property manager will have a high-level understanding of the building, but the building engineer knows that facility. They know what's broken, they know what's been fixed. They know where it's too hot or too cold. They know what lights have been changed. They know what's been done to save energy. They may even have ideas of what they want to do to save energy. So the building engineer interview, and even the property manager interview, is key to our data collection. We also collect utility bill data. The utility bills, including electricity and gas, help us in our analysis determine how much energy is being used, obviously. Once we've collected data, we then do a building energy model. And as you can see over here, here is a rendering of a building that was done in eQuest. eQuest is a software we use to model energy usage in a building. We put in factor, obviously you can see this building, we've considered how many stories there are, the roof type, the dimensions of the building, the orientation with north, west, east, south, air infiltration coming in, the mechanical systems, space cooling, chillers, boilers, the occupancy, we consider the occupancy schedules, a variety of parameters that determine how much energy is being used in this building. Down here you can see a comparison of the results in the building, or not comparison, but a profile of energy usage through this building. But the yellow over here, well, first of all, this is from January all the way through December. So you got 12 months. This is your average kWh per day for each month. And you can see the lighting energy usage, these little yellow bars, are pretty consistent throughout the year. But if you look at these blue bars in the middle, everything kind of looks blue in this graph at the moment except the top. You can see that these blue bars are showing more energy usage in the summer than the winter. This is your space cooling representation over here. So the model is telling us, not just what we're using in energy, but it's breaking out into pumps, fans, space cooling, space heating, ventilation, lighting, miscellaneous equipment. It's getting down into detail. Probably more detail than what the building owner and most people here want to know. But this basically helps us develop the baseline, then helps us identify and analyze what proposed measures